Alright, so the first thing we're going to do here is create the job. Just going to put your bounding box and set your date on, or your origins and all that other stuff. Any of the cutter paths up here, 2D or 3D, will automatically create, or you could just create one yourself. Now you got a relative size box, fixed size box, fixed size, you know, your X width, Y width. That's basically just going to be the entire width of your stock is what you're going to tell it. If you got a 2-inch by 2-inch piece. From a solid, it's going to give you from a solid. And cylinder, it's going to give you, of course, a round stock. From an extruded sketch, I'm assuming that's just going to be in case you're doing castings or something. I always use, well, for the most part, add stock or a relative size box. Then you got your add stock to sides and top, which will just add the stock all the way around. You know, if you want 100 thousandths on the sides, it's going to add it all sides. I use most of the cases add stock to all sides. Gives you plus X minus X, plus Y minus Y, plus Z minus Z, etc. Then you've got your fixture click. So if you set this up as an assembly and you add clamps to it, then you could go in here and tell it that those are part of the fixtures, whether it's a vise, whatever. Then here's for your work coordinate. Use original orientation. Basically, pick a part on here, tell it to Z. Pick another part, tell it which one's going to be X, etc. Use stock and orientation. That's going to use your stock, and then you pick where you want it to be, which is what I almost always use. You pick the center of it, pick wherever you want. You just have to pick the whatever face you want the Z direction to be at. I usually try to use that back corner right here because that's the fixed jaw on the Kurt. Down here you got program name, comment, work all sets if you're using multiple vices, whatnot. Click your check marks. First operation here, we got the drill. So you would pick the drill cycle up here if you wanted. Now, none of your tools would be set, so first thing, you go to library, click new mill tool down there at the bottom. And this is center drill, so you would click that box there, come down until you find center drill and pick it. You can set all your parameters if you want. Click OK. And you got your feeds and speeds here. Always calculates 5,040 inches for everything. Just over 2.5 thou chip load per tooth. You want to update because we got operations that depend on that tool. So you select yes, then click select. And that's going to pick the tool for this operation. Next, you're going to pick what you're trying to do. So you're going to pick this hole right here because that's what we're trying to drill. Edge 1, that's the edge of that hole. Then we're going to go to the heights tab. So you want to make sure that it's going from the top of the stock since this is the first operation, which we've got already selected. So we want it to go a negative 50 thousandths below the top of the stock. That's how deep into the work it'll go. And it's going to start drilling 10 thousandths above the top of the stock. Then you got your feed height. That's where it's going to actually start feeding from. And then on the last tab there, here we're just using drill and wrap it out. I use chip breaking or deep hole drilling for regular drill in most cases. So now that that's done, we'll go down here and duplicate that operation. Then we'll pick the operation that we duplicated because it'll come up like that. Now we're going to have to create a new tool for this one because we've only got a center drill if this is your first time. So we click New Mill Tool. In general, just your tool numbers, length offset, the diameter offset, and whatnot. So we're going to pick the little box here, scroll down, get us a drill, your tip angle, diameter, all of that jazz, and your feeds and speeds again over here. Click OK. Just click OK. Select it. Now the edge is already picked because we duplicated it. And here we're going to have to change the heights because we don't want to only drill 50 thousandths deep. So what I do is I always use from selection. Of course you got model top, model bottom, stock bottom, hole top, hole bottom. From selection, from the absolute origin, from chamfer width, and from chamfer diameter. So we use from selection for this, pick the bottom face. And then we're going to go, you could use the drill tip through, but you still have to enter a number, so I just put a minus 100 thousandths from the bottom. It's going to take it 100 thousandths below the bottom of that model. And then we're going to go here. Deep hole drilling, since we're going all the way through, we want it to peck drill and retract. I'm not sure that's the absolute best cycle, but I've broken some drills, so that's what I go with until someone can show me better. Then your dwell, your P number will be how many seconds you want it to dwell there. Then we're going to go to the pocket. So you'd have to click the pocket thing, pocket cycle. Click your library tool, New Mill Tool. Again, you got your tool length offset, your tool number 1, tool length offset number 1, diameter offset number 1, flood coolant, high speed steel, all that good stuff. Cutter, you're going to pick your flat end mill, put in your diameter, feeds and speeds, and we calculated this in HSM Advisor 3300. 24 inches a minute, giving us almost 2.5 thou per tooth, and we're running it 30 to 50% faster than that, and we're getting 3 thous a tooth. And then here's HSM Advisor. So you got your solid end mill, high speed steel, no special coatings. This tool's a inch and a half, 16 flutes. Run at 500 RPM, 24 inches a minute, 3 thou per tooth, 196 feet a minute, which is slower than it recommended, but it was too rough. So and you got your speed and feed overrides right there. We got less feed than we've got speed, just because it wasn't good running it the way that it's telling you to run it. Then you got your depth of cut, width of cut, slotting or pocketing if you're doing that. You got your chip thinning, high speed machining, your circular ramps and your scallops. We'll come back in and use some of that later on to adjust some of this. So you select the tool, go to your heights tab. Now we're just using a bounding box. You could use silhouette or selection. Bounding box is basically it's telling it the stock that you got there. If you're unsure, just hover over any of these things and they got a color flyout that tells you exactly what you got going on. Tool outside the boundary box will allow it to go outside. You got inside or center. And then this is an additional offset if you want to go further than just the tool diameter. And then we're doing rest machining since we already drilled the hole. In case it wants to go there, we want it to know there's no stock. Manual step over, stepping over 100 thousandths a pass. And manual step down, we're stepping down a 1/2 inch. Stock to leave, we're leaving 20 thousandths on the side, but we're leaving nothing on the bottom. Now here's your, so you got your tool, you got your work geometry, you got your heights tab, then you got your everything that's going on inside the work, and then you got everything that's happening outside the work, which is your lead in, lead out, your ramp, all of that good stuff. So we've got minimum retract. You can have full retract or the shortest path. The shortest path seems a little sketchy to me. You can preserve your rapids, or you can use all high feeds because it will feed faster than it will rapid for high-speed machining. It will preserve axial rapids, your Z rapids, or radial rapids, or it gives you control over all that stuff. This is your safe distance, how far off of the model it has to stay before it enters into one of these retracts. And if you try to adjust it too low, it'll give you a little error to the side and let you know that you're treading on a slippery slope, And then this is your stay down distance. If you got it set for 2 inches, the tool will have to move over 2 inches before it lifts the tool up. And this is your lift height, 10 thousandths, 100 thousandths, whatever you're trying to lift it at. Lead in, lead outs, horizontal and vertical lead in angles, or radius rather. And lead out, same thing right under it. Then you got your ramp style. You hover over it and it'll give you a blowout. Several different kinds to choose from. We're running a helix with 3 degree ramp angle. Maximum ramp step down is a 1/2 inch. And then the ramp radial height, clearance height, how high it's going to retract before it starts ramping in. 200 thousandths is what we're setting that at. 1/2 inch is just a long way for it to go. And you got entry positions, pre-drilled holes. Click your little check mark. It's going to regenerate that. We'll move on to the next one. Gotta pick your tool, because we don't have a tool yet, remember? So we're going to new mill tool. Tool 4, cutter, flat mill, 1/4 inch. Feeds and speeds, running 5,000 RPM, 22 inches a minute. Again, 30 to 50% faster than that. Start out slow and then we can ramp it up. And we got the old reduced shank right here. I didn't put the flutes all the way up on the model, so it'll show an error, but I ground the tool myself, so I know it's good. And of course, you got your bounding box or whatever. Here, we're going to go from selection, because we don't want the tool going outside that work, because it messed up the finish on the test part. So we want to contain it inside that bounding box right there. So we'll go tool center of the boundary, and it can't go outside of that box. It can go no further than the center of that line right there. So it will machine inside of that. 70 thousandths maximum step over. We got 100 thousandths right there, so we'll drop down 150 thousandths roughing step down. And on this one, we've got stock to leave unchecked. Normally, if you check it, 20 thousandths is pretty much what it runs with. You can adjust it as you see fit, but we're not using it at all. Again, 3 degree helix angle. And that just gets you in there a little bit faster. Click the little check mark. That's the operation we just generated. And as it's helixing in, it's also cutting. And then that's the one we just generated just now. So now we'll move on to the old slot cutter. Again, got to make a new tool. Click New Mill Tool. Slot mill. This one's 1.5 inches wide, 16 teeth. Okay, we're going to update because we got operations on it. Now, bound in box, that's all fine there. What we're going to do here is we're going to use check surfaces. Normally, if you click check surfaces, whatever you pick, the tool will avoid. If you click the little touch check surfaces box down there at the bottom, it will touch only the surface that you check. And that's what we need to use right now because we only want that tool to touch this surface. So then we're going to go to stock to leave. Now we got 200,000. Since this is a contour, it's not letting me step over that I can figure out how. So I'm doing it manually. So we know we got 200,000. So stock to leave, we'll leave 150,000. So we'll take 50,000 to pass. And we'll leave 10,000 on the bottom. So then we'll go ahead and generate that operation. Then we'll right click it, duplicate it, copy it, duplicate it, whatnot. Again, we'll take 50,000 off of that, so we'll leave 100. Go right back to it, right click it, duplicate it again. Go in, edit it, take another 50,000 off, so we'll go right to the passes tab. I'm going to edit that. Right to the passes, take 50 off of it. Now on this one we're going to take all but 10. We'll leave 10 top, 10 bottom. Duplicate that one last time, and this time we will just check, we will uncheck the stock to leave box, so it will leave no stock. So essentially we're just repeating the same operation 50,000 at a time until we don't have anything left on that part, leaving 10,000 to finish. Then we're going to come in and create a contouring operation, library, new tool. Well, actually we're picking the 1/4 inch that we've already got. Now on this one we're going to want to select this bottom edge. And since that's not the bottom of the part, we're going to go into the heights tab. We're going to go with from selection. As you can see, that it wouldn't be cutting all the way to the bottom. So we'll go from selection, pick that bottom face, and then we'll take 20 thousandths below that just to make sure that we've got it all. And then we'll take our stock and we'll go from selection on it, and we'll pick up the vertex, the top of the tooth as the vertex. And we've got our feed height linked to our top height, so it's 200 thousandths above that. So then we link our retract height to our feed height, so it's 200 thousandths above that. Then we link our clearance to our retract, so it's 400 above that. And they go in that order from bottom to top. So now we're going to move that operation up here underneath the second pocketing operation, so we won't have any tool changes. It'll just do that contour after it finishes doing the pocket operation. And all you got to do is just left click on it and move your mouse up. So now we're going to sketch a line, so that we have something to pick up for our contour operation on the gear teeth. So we'll pick the front plane because that's the flat plane. We'll hover on this circle right here, and then you get this dotted line, and you can see the little relations over there, and that's telling you that you're straight up and down on that center. So we'll hover outside of the gear tooth and click, and then come back inside and click again, so it creates our line that goes outside of it. And we know that line is perfectly straight right there. And then we'll go up here to our sketch pattern, drop down box, circular pattern. Now since we're still in the sketch, it already knows what we're trying to do essentially. But it's picked the center point to revolve around. So we're going to tell it we want 40 instances. It's 360 degrees, equal spacing. And it already knows that the line that we're wanting to pattern, but if not, you would put it in there, and it automatically shoots it around. So now we've got 40 lines in the center of each one of those teeth. So then we'll create the tool, new mill tool. Now we know that it's a 10,000th bottom, so we'll make the tool 8,000ths and see how that does. It's 45 degrees, so we'll make it 22 and a half degrees, and we have to we made this tool by hand. So we'll pick one line. Then we're going to go to the heights tab because it's going to be trying to drop only to the contour that we selected. So we'll go from selection, pick the bottom vertex. It's going to drop it all the way down to the bottom of that sketch. And of course we'll link all of these together. We'll take that one right down to the bottom and then link the rest to the top of cut right there. Link that one to the feed height, and we're golden. Now we got one tooth cut. So we'll not use duplicate, but make pattern. This is so awesome. I love this feature. So you're going to do make pattern. Now it wants to know, what are you revolving it around? Well, first we have to pick it. You can linear, mirror, duplicate, but we're doing circular. What do you want to rotate around? So we'll pick the cylinder, cylindrical face rather, 360 degrees, 40 instances, equal spacing, and there we go. 40 teeth cut, click check mark. Now we'll go up here and regenerate all the tool paths, because when you move operations around, any operations that rely on it are going to be voided until they're regenerated. Then we'll do stock simulation. All the colors at the bottom are each operation. They'll change as the tool touches. So it'll go green, blue, beige, purple, on and on. Of course, you're not actually seeing how the tool's moving because we're moving it so fast, but I don't got time for all that. Now again, remember, I didn't put the length of the flutes on there, so it's giving me all these errors at the top and telling me that the tool's rubbing, but I ground the tool myself, so I know that it's not rubbing. And that's what we got.